Hi guys, welcome to this first geometry video on isosceles triangles. So we're going to start off today with a little warm-up. The warm-up today is just testing your ability to apply some of the theorems that we've learned. So to this diagram. So if I look at this diagram here, I have 115, C, A, 45, and B. So in here, I definitely spot a triangle with 45 degrees, B, and an unknown unmarked angle, and I definitely know C. So we're going to apply some of the theorems that we learned in class this unit and ones in previous units. I know, okay, that according to the exterior angle theorem, the angle A and 45 have to add up to 180 degrees, which leaves me with a pretty simple calculation that A is equal to 180 minus 45, or A is equal to 135 degrees. Pretty simple calculation. For angle B, I'm going to have to hold off on angle B until I find this angle here. So I need to find this question marked angle first, and then I think I can fill in angle B. But you know what? I can go ahead and make a reasonable assumption that this angle here is going to be equal to this one because they're vertical angles, and that is one of the theorems that we learned in chapter 2 and in chapter 1 is that vertical angles are congruent. So 115 degrees up here. So if this is 45 and this is 115, that gives me a total of 160 degrees, leaving B to equal 20 degrees by using the triangle interior angle sum theorem. And then 115 and C. I know that C and 115 have to be a linear pair. So if I do 180 minus 115, that leaves me with 65 degrees for C. And then if you look, C is an exterior angle, and the two opposite interior angles, B and 45, add up to 65, meaning that we got everything correct because we can verify it with that second triangle exterior angle theorem. So today we're going to talk about isosceles triangles. So again, we are learning to find missing sides or angles in isosceles triangles. They're important for finding measures in complex diagrams. And you'll know you're successful when you can find the missing sides or angle measures of an isosceles triangle using the given information. So, parts of an isosceles triangle, okay? The vertex angle is up here, and the vertex angle is the angle across from the base of the isosceles triangle. Oop, and instead of typing up here, so I'm going to just drag that down here. So the angle across from the base angle, excuse me. The base angles are the two congruent angles that sit on the base and one of the congruent sides. And the legs, those are the congruent sides of the isosceles triangle. Those are the congruent sides of the isosceles triangle. So by those definitions, okay, these right here, so AB would be an example of a leg. And AC, so side AC would also be an example of a leg. The vertex angle, we could name it BAC, so we could call that angle BAC. We could also call it CAB. But since it's the only angle that has a vertex of A, we're just going to refer to it as angle A. So this is angle CAB. The base angles, we're just going to follow that convention of using one letter. Angle B is a base angle, and angle C is a base angle. And BC, right here, this is the base of our isosceles trapezoid. So that's just a review from some of the terms from chapter 1. But we just need to make sure that we have the specific names for them because, oh, and you know what? I missed the base term down here. It was hidden underneath this little thing here. So base, okay, the base, the side that the isosceles triangle sits on, it is not congruent to the legs. So side BC, so switch back to my marker tool here, side BC is going to be the base of this isosceles triangle. Okay, so the isosceles triangle theorem, and this is really, really important. If a triangle is isosceles, then its two base angles are congruent. It seems, it seems like it's not saying much, but it's actually one of the most important theorems that we have about an isosceles triangle. We know that if these two angles are, or these two sides are congruent, it automatically means, okay, that these two angles are congruent. So the converse, so converse meaning opposite of that, is that if a triangle has two congruent angles, so if I know that a triangle has two congruent angles, it automatically proves that the other two sides are congruent. So it also states if the angles of an isosceles triangle are congruent, the opposite sides are forced to be congruent. So those are just some really important theorems to keep in mind for later. We are going to use them when it comes to calculating things and just being certain that we're working with an isosceles triangle. And finally, okay, the isosceles triangle bisector theorem. In an isosceles triangle, so here's an isosceles triangle, EDF, the bisector of the vertex angle, so if I draw this bisector in here, that bisector is the perpendicular bisector of the base. And it creates four true statements, okay? The first is that this angle, FEG, and DEG, those two angles are congruent. So these ones up here are marked as congruent. It creates two 90-degree angles, EGF and EGD. It makes it so that GD and GF are congruent. And it also means that DG and GF are both half the original length of DF. So those are some important theorems. It also creates two triangles, okay? You have a triangle DGE and you have a triangle EGF as well. So, sample here. Solve for the measure of angle C, okay? Here I have 48 degrees and I have nothing else marked, okay? But I do know that this is an isosceles triangle because of the congruent markings. So I can apply the isosceles triangle theorem, which then states that C and B have to have the same measure. So I'm going to mark it with a letter C. So I can write an equation that follows the triangle angle sum theorem of stating 48 plus C again equals 180 degrees. Okay, so I can combine my like terms, and I get 48 plus 2C is equal to 180. So I can subtract 48 from both sides. I'd get 2C is equal to 132. And then dividing both sides by 2, I would get C is equal to 66 degrees. So each angle and angle C here would be 66 degrees. So if you add them all up, 66 is 132, plus 48 is 180 degrees in total. Determine the measurement for angle A. Okay, so this is an interesting one, okay, because A is an exterior angle. So I know, okay, that 80 plus this angle here have to equal A. But I also know that A plus this angle here are supplementary. So I'm going to have to do a little bit of detective work to first find these missing angles, and we're going to call them X, because I don't know them yet. So I'm just going to replace them with a variable. But if I do the triangle sum theorem, okay, 80 plus X, so 80 plus X has to equal 180 degrees. So I can combine my like terms to get 80 plus 2x equals 180. So my like terms are combined. I can subtract 80 from both sides to get 2x equals 100. So x equals 50. And I did this using my Isosceles Triangle theorem because I know that this and this side are congruent, so this and this angle have to be congruent. Now, since x is 50, okay, I can write that in my diagram. Since I know x is 50, I do know that 50 and A have to add up to 180 degrees as well. So 50 plus angle A have to add up to 180 degrees. So just some quick math really quick, subtracting 50 from both sides. I'm going to get that A has to be equal to 130 degrees. No sweat. All right, this one's a little more complicated. So we stumble upon this diagram here. I have an isosceles triangle. It is marked as such, okay? I do know that this and this are an isosceles triangle. And they tell me that this side, u to t, is 18 centimeters. You know what? So I'm going to go ahead and just write that over here right away. Since I know those two sides are congruent. Oh, that was one of the things that they asked me for in the problem, was that they wanted me to find the measure of SU. Well, SU happens to be one of the sides of the isosceles triangle, which by definition must be congruent. So there's my measure for that. Now they want me to find the measure of S, U, and V. So they're asking me to find this measure here. And they want me to find the measure here, angle S. Well, I do know that 50 degrees is across from one of the opposite sides, which means, or congruent sides, excuse me, which means the other angle that is across from a congruent side must also be equal. So, since I know this is 50, this one must also be 50, since it's an isosceles triangle. Which leaves, so if I have this mystery angle here, angle Y, 50 and 50 is 100, leaving 80 degrees for Y. Now, I know that some of you might be tempted to say, that looks like 90 degrees. But remember, diagrams are deceiving, and this was never marked as 90 degrees. So if Y is 80 degrees, X plus Y must be equal to 180 degrees, so that leaves 100 degrees for SUV. And if you combine the two opposite interior angles, this exterior angle would have to be 50 plus 50, or 100 degrees. And then finally, triangle XYZ is known to be isosceles. So XYZ is known to be isosceles. Find the measures of angle X and angle Y. And all they gave me was angle Z down here. They did tell me that this is, they did tell me that this was 90 degrees. Okay. Which means it's the perpendicular bisector. Okay. That does say, though, easily, okay, that this is 56 degrees. Since we know XYZ is isosceles, we can mark it as such. XYZ is isosceles. So 56 and 56. So 56 and 56 gives me 112 degrees when added together. So 56 plus 56 is 112 when it's added together. So angle Y, which is both of these up here, okay, that would be 180. Take away the 112 that I've already used, leaving you with 68 degrees for angle Y. And if I wanted to find one of these smaller ones in here, if I wanted to find this angle here, I could do 56 plus 90, and then in here this would be 34 degrees. And I could also do it by splitting the 68 into 2, since that's the definition of angle bisector. So just a little bit of plus standard on that there, is that you could also find the measure of these smaller interior angles as well. All right, guys, that's it for isosceles triangles. Good luck on your homework.